All right, so now we are doing question 11, and in question 11 we're working with probability. So this is the problem given to us. Okay, and in order for us, we need to solve this problem. In order for us to solve this problem, we have to analyze the statement given to us. We are told that event A and event B are mutually exclusive. It is given that a probability of B is twice probability of A, and the probability of A or B, the union of it, is equal to 0.57. And we are required to calculate the probability of B, and it's 3 marks. Okay, this is just a giveaway marks. Why am I saying so? Look, this is easy. You just have to analyze the information. 11.1. Okay. First thing, you are told that events A and B are mutually exclusive. Before you even tackle this problem, you have to understand what is meant by the term mutually exclusive. If you don't understand mutually exclusive, that's why you'll be having the problem. Because when we say events are mutually exclusive, we are trying to say that the probability of their union, of which is A or B, some will write it as A union B, is equal to the probability of A plus the probability of B. So this term, let's say mutually exclusive, gives you this result. So in this case, we have the probability of A or B that has to be equal to the probability of what? Of A. And in this case, since the probability of A and the probability of B are unknown, and we can write the probability of B in terms of A, so we are going to have one unknown, two probability of A in this case. So we are told the probability of the union that it is 0.57, which is equal to, when you add the two, you have the coefficient of 1 here, and we have a coefficient of 2, so we'll be having 1 plus 2 what? Probability of A, which then gives you 0.57 equal to 3 probability of A, then divide both sides by 3. So the probability of A in this case will then be equal to 0.19. So the fact that now I do have the probability of A, I can then go and write probability of B, because I'm told that probability of B is twice probability of what? Of A, of which is equal to 2 times 0.19, of which will be 0.38. You can even check now the probability of A plus the probability of B. It's 0.19 plus 0.38, of which is something that will give you 0.57. That shows that you did everything correct. Okay, then let us go to 11.2. 11.2, we are given two identical bags, of which are bags that are filled with balls, of which is bag A and bag B. We are told that bag A contains 3 pink and 2 yellow balls, and bag B contains 5 pink and 4 yellow balls. So we are told that it is equally likely that bag A or bag B is chosen. Okay, if they say it's equally likely, that means the probability of choosing A or B at random is 50-50%. Each ball has an equal chance of being chosen from the back. Okay, a ball is chosen at a random, and a ball is then chosen at a random from the back. So we have random choosing. In fact, we choose the ball randomly. Again, we are not biased. We can choose it from any bag. So now the question says I have to represent the information by means of a tree diagram, clearly indicating the probability associated with each branch of the tree diagram and write down all the outcomes. Okay, it's 4 marks, meaning we have to work. We have to work in this case. Okay, but it's not something that will trouble us. Let us look at this 11.2. Okay, now I'm told that I have to represent the information by means of a tree diagram, clearly indicating the probabilities associated with each branch of the tree diagram and write down all the outcomes. So this is 11.2. I have two bags, bag A and bag B. Bag A consists of 5 balls. 3 are pink, 2 are yellow, and bag B consists of 9 balls. 5 are pink, 4 are yellow. So this is what I have from the information that I just collected now. 1, I have 2 bags. It's bag A and bag B. And on the bag, on 2 bag, I have 2 colors, yellow ball and pink ball. Again, it's a yellow ball as well as pink ball. So the probability of picking a bag A, I'm told that it is half, and the probability of picking bag B is half. And I'm told that here I have how many yellow balls on bag A? I have 2. So there are 2 yellow balls over how many? Over the sample, and 3 pink over the sample space. And in this case, how many yellow balls do I have? I have 4 yellow balls over the sample space, and here I have 5 over what? The sample space. So in this case, the probability of picking a ball and that ball come out to be yellow is equal to what? It's half times what? 2 over 5, of which is what? Of which is 2 over 10, of which is 0.2. Okay. And then the probability of picking bag A and picking what? A pink ball. It's what? It will be half times the 3 over 5, of which is the 3 over what? Over 10. Okay, it's 3 over 10 is 0.3. By the way, let me use calculator to verify. Yes, it's 0.3. Okay, and then now I want to look at the probability of picking a bag B multiplied by probability of picking a yellow. It will be half times what? Times 4 over 9. So this one I end up with 4 over what? Over 18, of which is equal to what? Let me use my calculator. 4 divided by 18, I get what? 2 over 9. 2 over 9. And then here the probability of picking bag B multiplied by probability of picking pink ball, it will be half times 5 over 9, of which it should be 5 over 18 in this case. So I think I managed to write all the possible probabilities for it to look clear. Let me write it here now. So probability of A times probability of yellow is equal to 0.2 probability of A times the probability of pink ball is equal to 0.3, and the probability of B times the probability of picking what? A yellow ball is equal to 2 over 9. Probability of picking B times the probability of picking pink ball is equal to 5 over 18. And then let us look at follow-up questions. What is the probability that a yellow ball will be chosen from bag A? That one is straightforward. Where is bag A? This one. It's yellow chosen from bag A. So 11.2.2. That one, it's a probability of A times the probability of Y is equal to 0.2. So that probability, okay, that probability of A and Y, in this case, it will be what? 0.2. We're done. 11. What is the probability that a pink ball will be chosen? Remember, a pink ball can be chosen here. A pink ball can be chosen here, can also be chosen here. So in order for you to write the conclusion here, it is the probability of ball being chosen from A times ball being chosen from here plus a probability of a ball being chosen from B times a ball being chosen from P, of which is equal to what? From A it will be 0.3 plus, and from B it will be 5/18. So now if you add 0.3 plus 5/18, the result is what? The result is 26/45. 26/45. So yeah, I think I'm done with all the problem, or with answering all the questions that were related to question 11, of which is